The video will explain you about the solid, semi-solid and synthetic lubricants of fuel chemistry paper, which is in chemistry subject of B.Sc course. The contents of this video are solid lubricants, semi-solid lubricants and synthetic lubricants. Let us know about the solid lubricants. A solid lubricant is a film of solid material composed of inorganic or organic compounds or of metal. These lubricants reduce friction by separating two moving surfaces under boundary conditions. They are used either in the form of dry powder or mixed with water or oil. Low spots on the surface of moving parts are filled by these lubricants, which then form solid film having low frictional resistance. The usual coefficient of friction between solid lubricants is between 0.005 and 0.01. Solid lubricants are generally used where operating conditions are such that a lubricating film cannot be secured by use of lubricating oils or greases, where contaminations of lubricating oil or grease by dust or grit particles is not acceptable. For example, commutator bushes of electric generators and motors, where the operating temperature or load is extremely high even for semi-solid lubricants to stick in position, and where combustible lubricants have to be avoided. Many solid lubricants are given here. It is molybdenum disulfide, which is also known as monosulfide, polytetrafluoroethylene, also known as Teflon, graphite, bentonite, boron nitride, talc, cadmium iodide, silver sulfate, tungsten disulfate. The two most common and important solid lubricants used are molybdenum disulfide and graphite. Let us discuss about these two in detail. Graphite. It is most widely used of all solid lubricants. It consists of multitude of flat plates, one atom thick, which are held together by only weak bonds, so that the force to shear the crystals parallel to the layers is low. Consequently, the parallel layers slide over one another easily. Hence, it has low coefficient of friction. It is very soapy to touch, non-inflammable, resistant to oxidation by air below 375 degrees Celsius, and can be used up to very high temperature in the absence of air. Suspension of graphite in oil or water is prepared in the presence of tannin, which acts as an emulsifying agent. When graphite is dispersed in oil, it is called as oil dag, and when it is dispersed in water, it is called as aqua dag. Oil dag is found particularly useful in internal combustion engines because it forms a film between the piston rings and cylinder and gives a tight fit contact, thereby increasing compression. On the other hand, aqueduct is useful where a lubricant free from oil is needed. For example, foodstuff industry. Graphite is mixed with grease to form graphite grease. The applications of graphite as lubricant in air compressors, lathes, general machine soap works, foodstuff industry, railway track joints, open gears, chains, cast iron bearing, internal combustion engine, etc. Second one is molybdenum disulfide. It has sandwich-like structure, which is shown here in the figure, in which a layer of molybdenum atom lies between two layers of sulfur atom. It provides low shear strength in a direction parallel to the layers because of poor interlaminar attraction. Molybdenum disulfide has very low coefficient of friction and is thermally stable in air up to 400 degrees Celsius. Its fine powder may be sprinkled on surfaces sliding at high velocities. As a result, it fills low spots in metal surfaces, forming the film. It also used along with solvents and in greases. Next is semi-solid lubricants or greases. Semi-solid lubricants or greases consisting of soap dispersed throughout a liquid lubricating oil. Greases are prepared by saponification of fat followed by adding hot lubricating oil with constant agitation. The total amount of mineral oil added determines the consistency of the finished grease. Grease may vary from a heavy viscous liquid to that of a stiff solid mass. To improve the heat resistance of grease, inorganic solid thickening agents are added. Greases have higher shear and frictional resistance than oil. Classification of greases. Since the consistency, water resistance, oxidation resistance, and the temperature up to which a grease can be used are all decided by the nature of soap. Thus, grease are classified on the basis of soap used in their manufacture. Important greases are calcium-based grease. These grease are prepared by mixing a calcium soap with petroleum oil. They are insoluble in water. These can be used up to 80 degrees. These are also called cup grease. Second one is soda-based grease. These greases are prepared by mixing of sodium soap with petroleum oil. They are soluble in water. These can be used up to 175 degrees Celsius. These greases are used in ball bearing. Third one is lithium-based grease. These greases are prepared by mixing of lithium soaps with petroleum oils. They are water resistant. They have high stability and suitable for use at higher temperatures. Grease is a semi-solid consisting of soap dispersed throughout a liquid lubricating. The liquid lubricant may be a petroleum oil or even a synthetic oil, and it may contain any of additives for specific requirement. Grease are prepared by saponification of fat such as tallow or fatty acid with alkali like lime, caustic soda, etc., followed by adding hot lubricating oil with constant agitation. Grease have higher shear or frictional resistance than oils and therefore can support much heavier loads at lower speeds. They have a tendency to separate into oils and soaps. The main function of soap is to act as thickening agent so that grease sticks firmly to the metal surface. Applications of grease. Grease are used in rail axle boxes or any other such applications where oil cannot remain in place due to high load, low speed, intermittent operation, sudden jerk, etc. In bearing a gear which work at high temperature. In machines preparing paper, textiles, edible articles, spurting of oil is desirable during their manufacture. In situations where bearing needs to be sealed against entry of dust, dirt, grit or moisture, as the greases are more resistant to contamination by these agents. The third one is synthetic lubricants. Petroleum-based lubricants can be used under abnormal conditions like extremely high temperature, chemically reactive atmosphere, etc. by employing certain specific additives. However, synthetic lubricants have been developed which alone can meet the most drastic and severe conditions such as those existing in aircraft engines in which same lubricant may have to be used in the temperature range from -50 degrees to 250 degrees Celsius. Such a lubricant should possess low freezing point, high viscosity index, and also should be non-inflammable. Modern synthetic lubricants possesses in general the following distinguishing characteristics: non-inflammable, high flash points, high thermal stability at high operating temperatures, high viscosity index, chemical stability, etc. Important synthetic lubricants are polymerized hydrocarbons like polyethylene, polypropylene, polybutylene in the molecular weight range of 500 to 50,000 are residue free, light in color, free from non-hydrocarbon impurities, chemically non-reactive and high temperature lubricants. Polyglycols and related compounds like polyethylene glycol, polypropylene glycol and polyglycidyl ether and higher polyalkylene Oxides can be used as water soluble as well as water insoluble lubricants in rubber bearing and joints. Their viscosity index is high and these are used in roller bearing of sheet glass manufacturing machines. It may be pointed that polyethylene oxides undergo thermal decomposition at high temperature to evolve volatile oxidizable products, so these are not useful as lubricants at high temperature. Organic amines, imines and amides. These are good synthetic lubricants since they possess low pour point and high viscosity index. They can be used under temperature conditions of -50 to 250 degree Celsius. Next one is silicones. They are very good synthetic lubricants because they are not oxidized below 200 degrees Celsius and possesses high viscosity index. These are frequently used for low temperature lubrication purposes. It may be pointed that silicones are oxidized quickly above 200 degrees and undergo cracking process at about 230 degrees Celsius. So they are not employed for high temperature applications. And the last one is fluorocarbons. Fluorocarbons are not decomposed by heat, not easily oxidizable and chemically inert and resistant to chemicals except molten sodium. Thank you.